sequences and series recurrence relations. So we have this arithmetic sequence. U1 is the first term, U2 is the second term, and so on. So the first term is 10. The common difference between the terms is 2. The nth term formula, substitute the values in. So this formula will give us any term anywhere in this sequence. So the first term, second term, we put in n equals 2, and the 50th term, 108. The key thing here is you don't have to generate every single term to get to the 50th term. You can just put in n equals 50 into the formula here, and it will give you the 50th term directly. I don't need to work out the third, the fourth, the fifth, all the way up to the 50th term. An alternative way of generating this sequence is to say that if we take any term and add 2, we get the next term. So for instance, if I want the fourth term, I take the third term, the term before, and I add 2. So we can write this mathematically like this. So take any term in the sequence and add 2, and it will give you the next term, which we can write as un plus 1. But you need to state the first term in the sequence as well. So u1 here is 10, and then to generate the next term I'm going to use this recurrence relation and say that u2 is equal to the previous term plus 2. The previous term is 10 plus 2, so we get 12. And then I can generate the third term and say, well, it's the previous term plus 2. The previous term is 12 plus 2, and I get 14. And then if we continue like this, u4 is equal to the previous term plus 2. The previous term I've just worked out is 14 plus 2, and I've just worked out the fourth term in the sequence. Now, this method of working out the terms is okay for a computer. A computer can really calculate fast. It can generate any number of terms really quickly. It's a very, very fast adding machine. But for the purpose of what we're doing here, it's slow. To generate the 10th term, I have to start with the first term, work out the second term, then work out the third, then the fourth, and continually work out all of the terms, 9th term, and then I get to the 10th term. So for this recurrence relation for sequences, we have to state the first term so we know where we start from, and then a relationship between the previous term and the next term in the sequence. So here we know that the next term is the previous term plus 4. So u2 will be the previous term, which is u1 here, plus 4. 11. u3 will be the previous term, which is u2, so that's 11, plus 4, and so on. But you can't work out u30 directly. There is no nth term formula here. To work out the 30th term, you have to work out all of the terms. The 4th term, the 5th, the 6th term, the 29th term, and then finally the 30th term. Example 2. The first term in a sequence is p. To work out the next term, we take the previous term and we square it first, and then we subtract 1. So to work out the second term, you take the previous term, which is u1, which is p, you square it, and you minus 1. To work out the third term, you take the previous term, which is p squared minus 1, in brackets, you square it, you minus 1. So if the second term is 0, what's the value of p? And given that p is negative, now the second term was p squared minus 1. We make that equal to 0 when we solve, so we have an even power, so we'll get a plus or minus when we solve. And because we've said that p is negative, then p equals 1 is discarded, p equals minus 1. So if the first term is p, and we generate the actual terms of this sequence, so the first term is p, and p is minus 1. The next term is the previous term squared minus 1, which gives 0. The next term is the previous term, which is 0, squared minus 1. And you can see that the terms alternate between minus 1 and 0. So what would you get if you add the first 200 terms together of this sequence? Well, we know that half of the terms will be minus 1 and half of the terms are 0. So if you add those together, you get a sum of minus 100. For practice, try these problems.